W30 wire connectors are lever-type wire connectors designed for connecting up to 4 solid conductors, making them suitable for common electrical wiring tasks. They are recognized for their convenience and ease of use. Backstab connections found in some outlets and switches involve inserting a wire into a hole where it presses against a metal contact. These connections are not as secure as screw terminals and can degrade over time. This can lead to loose connections, increased resistance, heat buildup, and potentially fire hazards. W30 connectors, however, employ a spring-loaded lever that securely clamps down on the conductors. This design ensures a more reliable connection that is less prone to loosening or failing over time. It is rational to trust W30 wire connectors more than backstab outlets and switches. The clamping mechanism in W30 connectors provides a more secure and consistent connection compared to the simple pressure contact of backstab connections. Furthermore, W30 connectors are engineered to meet specific electrical codes and standards, ensuring they adhere to safety and performance requirements. This is not always guaranteed with backstab connections, which have a history of issues and code violations in some areas. The benefits of using W30 connectors are: firstly, they provide secure and reliable connections, minimizing the risk of loose wires and electrical faults. Secondly, they are easy to use with a simple lever action, making wiring tasks faster and more efficient. Thirdly, their compact design saves space in junction boxes and electrical panels. Fourthly, they meet established electrical codes and standards, ensuring compliance and safety. Fifthly, they can be used in a wide range of electrical wiring applications, offering versatility for different projects. In conclusion, W30 wire connectors present a reliable and convenient solution for connecting solid conductors in electrical wiring. Their superior clamping mechanism, adherence to electrical codes, and ease of use make them a safer and more dependable alternative to backstab outlets and switches. Therefore, it is logical to have greater confidence in W30 connectors when making electrical connections. Selecting the right type of wire connector is important for ensuring safe and reliable electrical connections. Wire connectors serve the purpose of joining 2 or more wires together to create a continuous electrical circuit. There are several types of wire connectors available, each designed for specific applications and wiring needs. The most common types are: firstly, wire nuts, which are also called twist-on connectors. These are among the most widely used type of wire connector. They consist of a plastic cap with a tapered internal thread. To use a wire nut, you strip the ends of the wires you want to connect, twist them together, and then screw the wire nut over the twisted wires. Wire nuts are available in various sizes to accommodate different wire gauges and the number of wires being connected. Secondly, push-in connectors, also known as push-in wire connectors. These connectors offer a solderless and screwless way to join wires. They feature small openings where you insert stripped wires, and an internal mechanism that grips the wires to create a secure connection. Push-in connectors are easy to use and save time compared to wire nuts, particularly when connecting multiple wires. They are typically used for connecting solid wires in lighting fixtures, receptacles, and switches. Thirdly, terminal blocks are modular connectors consisting of an insulated housing with metal terminals. Wires are connected to the terminals using screws or spring clamps. Terminal blocks are used for creating organized and secure connection points in control panels, distribution boards, and electronic equipment. They provide a neat and professional way to terminate wires and make connections. Fourthly, splicing connectors are designed for making inline splices or connections between 2 wires. They often consist of an insulated body with internal contacts that grip the wires. Splicing connectors are used in various applications, including extending wires, repairing damaged wires, and making connections in junction boxes. Fifthly, crimp connectors are commonly used for making connections between wires and terminals or components. They involve inserting the wire into a metal sleeve or barrel and then crimping it with a crimping tool to create a secure mechanical and electrical connection. Crimp connectors are used in automotive, marine, and industrial applications where vibration and environmental factors are concerned. Sixthly, insulation displacement connectors (IDCs) are designed to make connections without stripping the insulation from the wires. They feature sharp metal contacts that pierce the insulation and make contact with the conductor when the connector is pressed or crimped onto the wire. IDC are used in telecommunications, data networking, and low-voltage power applications. Seventhly, twists-on wire connectors with wings. These are similar to standard wire nuts but feature integrated wings or levers that make them easier to grip and twist onto the wires. The wings provide added leverage and comfort, reducing hand fatigue during installation. Eighthly, weatherproof wire connectors are designed for use in outdoor or wet environments where moisture and corrosion are a concern. They feature sealed housings and waterproof seals to protect the connections from water, dirt, and other contaminants. Weatherproof wire connectors are used in landscape lighting, irrigation systems, and outdoor electrical equipment. When selecting a wire connector, consider factors such as: firstly, wire gauge. The size of the wires you will be connecting determines the appropriate connector size. Secondly, the number of wires determine the number of ports. Thirdly, the environment, whether the connector will be exposed to moisture, heat, or chemicals. Fourthly, the application, whether the connector will be used for power, data, or signal connections. Fifthly, the voltage and current, whether the connector is rated for the intended voltage and current levels. Choosing the right wire connector ensures reliable electrical connections and minimizes the risk of electrical hazards. Always follow manufacturer's instructions and electrical codes when making wiring connections. Understanding basic electrical concepts is important for anyone working with electrical systems, whether you are a homeowner doing minor repairs or a professional electrician. These concepts provide a foundation for understanding how electricity works and how to work safely with it. Firstly, voltage, measured in volts. It is the electrical potential difference between 2 points in a circuit. It is the driving force that causes electric charge to flow. Voltage is often compared to water pressure in a pipe, with higher voltage representing higher pressure. Common voltage levels in residential wiring include 120 volts for lighting and small appliances and 240 volts for large appliances like ovens and dryers. Secondly, current, measured in amps. It is the rate of flow of electric charge through a circuit. It is the amount of electricity flowing past a given point per unit of time. Current is often compared to the flow rate of water in a pipe, with higher current representing a faster flow rate. The amount of current that flows in a circuit depends on the voltage and the resistance of the circuit. Thirdly, resistance, measured in ohms. It is the opposition to the flow of electric current in a circuit. Resistance is caused by the materials and components in the circuit that impede the flow of electrons. Resistance is often compared to the diameter of a pipe, with higher resistance representing a narrower pipe. The resistance of a circuit determines how much current will flow for a given voltage. Ohm's law, which is a fundamental law of electrical circuits, states that the voltage across a conductor is directly proportional to the current flowing through it and the resistance of the conductor. Mathematically, Ohm's law is expressed as voltage equals current times resistance, or volts equals amps times ohms. This formula can be rearranged to solve for any of the three variables if the other two are known. For example, to find a current, divide voltage by resistance, or amps equals volts divided by ohms. Fourthly, power, measured in watts. It is the rate at which electrical energy is transferred or used in a circuit. Power is the product of voltage and current. Mathematically, power equals voltage times current, or watts equals volts times amps. Power is used to calculate the energy consumption of electrical devices and appliances. For example, a light bulb with a power rating of 60 watts consumes 60 joules of energy per second. There are two main types of electrical circuits. Firstly, series circuits, in which components are connected one after the other along a single path. In a series circuit, the current is the same through all components, but the voltage is divided among the components. If one component fails in a series circuit, the entire circuit is broken and no current flows. Secondly, parallel circuits, in which components are connected along multiple paths. In a parallel circuit, the voltage is the same across all components, but the current is divided among the components. If one component fails in a parallel circuit, the other components continue to function normally. Electrical safety is paramount when working with electrical systems. Always follow safety precautions to prevent electric shock, burns, and other hazards. Some important safety tips include: firstly, always turn off the power at the circuit breaker before working on any electrical circuit or device. Secondly, use insulated tools to prevent electric shock. Thirdly, never work on electrical systems in wet or damp conditions. Fourthly, inspect electrical cords and devices for damage before use. Fifthly, do not overload electrical circuits or outlets. Sixthly, use ground fault circuit interrupters, GFCIs, in areas where there is a risk of water exposure, such as bathrooms and kitchens. Understanding these basic electrical concepts is essential for working safely and effectively with electrical systems. Always consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. Wire gauge refers to the size of a wire, which is typically measured using the American wire gauge (AWG) standard. The AWG system assigns a numerical value to each wire size, with smaller numbers indicating larger wires and larger numbers indicating smaller wires. Wire gauge is important because it determines the amount of current that a wire can safely carry. Thicker wires have lower resistance and can carry more current than thinner wires. Using a wire that is too small for the intended current can cause the wire to overheat, potentially leading to insulation damage, fire hazards, and equipment failure. The current carrying capacity of a wire is determined by several factors, including: firstly, the wire gauge; secondly, the type of insulation; thirdly, the ambient temperature; fourthly, the installation method. Electrical codes such as the National Electrical Code (NEC) provide guidelines for determining the appropriate wire size for different applications based on these factors. The NEC includes tables that specify the allowable ampacities, or current carrying capacities, for various wire types and sizes under different conditions. For example, NEC Table 310.15b16 lists the ampacities for insulated conductors rated up to 600 volts. When selecting a wire gauge for a particular application, it is important to consider the expected current draw of the circuit or device being powered. The wire gauge should be chosen so that its ampacity is equal to or greater than the maximum current that will flow in the circuit. It is also important to consider any voltage drop that may occur over long wire runs. Voltage drop is the reduction in voltage that occurs as current flows through a wire due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, use larger wires or shorten the wire run. Here are some general guidelines for wire gauge selection. Firstly, for general lighting and receptacle circuits in residential wiring, 14 AWG wire is commonly used for 15 amp circuits and 12 AWG wire is used for 20 amp circuits. Secondly, for larger appliances such as ovens, dryers, and air conditioners, 10 AWG, 8 AWG, or larger wires may be required depending on the appliance's power consumption. Thirdly, for low-voltage circuits such as those used for landscape lighting or security systems, smaller wire gauges such as 18 AWG or 20 AWG may be sufficient. Fourthly, for long wire runs, such as those used for outdoor lighting or remote sensors, larger wire gauges may be necessary to minimize voltage drop. Always consult with a qualified electrician or refer to the NEC for specific wire gauge requirements in your area. Using the correct wire gauge is crucial for ensuring safe and reliable electrical connections. Understanding voltage drop is essential for designing and troubleshooting electrical circuits, particularly in applications where long wire runs are involved. Voltage drop refers to the reduction in voltage that occurs as electric current flows through a conductor due to its resistance. As current flows through a wire, some of the electrical energy is dissipated as heat due to the wire's resistance. This energy loss causes a decrease in voltage along the length of the wire. Voltage drop is typically expressed as a percentage of the source voltage. For example, a voltage drop of 3% means that the voltage at the end of the wire is 3% lower than the voltage at the source. Excessive voltage drop can have several negative effects. Firstly, reduced equipment performance. Electrical devices and appliances may not operate properly if the voltage is too low. Motors may run slower, lights may be dimmer, and electronic equipment may malfunction. Secondly, overheating wires. Voltage drop causes wires to heat up, which can lead to insulation damage, fire hazards, and premature equipment failure. Thirdly, increased energy consumption. Voltage drop causes more current to flow in order to deliver the required power to the load, resulting in higher energy consumption and increased electricity bills. The amount of voltage drop in a circuit depends on several factors. Firstly, the wire length. The longer the wire, the greater the voltage drop. Secondly, the wire gauge. Smaller wires have higher resistance, resulting in greater voltage drop. Thirdly, the current. The higher the current, the greater the voltage drop. Fourthly, the wire material. Different materials have different resistivities, which affects voltage drop. Copper is commonly used due to its low resistivity. Fifthly, the temperature. The resistance of a wire increases with temperature, which can increase voltage drop. To calculate voltage drop, you can use the following formula: voltage drop equals current times resistance. The resistance of a wire can be calculated using the formula resistance equals resistivity times length divided by area. To minimize voltage drop in a circuit, you can firstly use larger wires. Increasing the wire gauge reduces resistance and voltage drop. Secondly, shorten wire runs. Reducing the length of the wire decreases voltage drop. Thirdly, reduce the current. Minimizing the current draw of the circuit reduces voltage drop. Fourthly, use low resistance materials. Selecting materials with lower resistivity, such as copper, reduces voltage drop. Fifthly, use multiple parallel conductors. Splitting the current among multiple parallel conductors reduces voltage drop in each conductor. Electrical codes such as the NEC provide guidelines for maximum allowable voltage drop in different types of circuits. For example, the NEC recommends that the voltage drop in branch circuit should not exceed 3% and the voltage drop in feeder circuit should not exceed 5%. It is important to calculate and minimize voltage drop to ensure proper equipment operation, prevent overheating, and comply with electrical codes. Always consult with a qualified electrician or refer to the NEC for specific voltage drop requirements in your area. Understanding electrical codes is important for anyone working with electrical systems to ensure safety and compliance. Electrical codes are a set of regulations and standards that govern the design, installation, and maintenance of electrical systems. These codes are developed and enforced by various organizations and government agencies to protect people and property from electrical hazards. The primary purpose of electrical codes is to minimize the risk of electrical shock, fire, and other electrical-related accidents. They provide guidelines for safe wiring practices, equipment installation, and system design. Compliance with electrical codes is mandatory in most jurisdictions, and failure to comply can result in fines, penalties, and legal liabilities. The most widely adopted electrical code in the United States is the National Electrical Code, NEC, which is published by the National Fire Protection Association, NFPA. The NEC is updated every 3 years to incorporate new technologies, address emerging safety concerns, and clarify existing requirements. The NEC covers a wide range of electrical topics including firstly, wiring methods. It specifies the types of wiring methods that are permitted for different applications, such as conduit, cable, and wiring devices. Secondly, overcurrent protection. It requires the use of circuit breakers and fuses to protect electrical circuits from overloads and short circuits. Thirdly, grounding and bonding. It establishes requirements for grounding and bonding electrical systems to minimize the risk of electric shock. Fourthly, equipment installation. It provides guidelines for the proper installation of electrical equipment, such as lighting fixtures, receptacles, and appliances. Fifthly, hazardous locations. It addresses the installation of electrical equipment in hazardous locations where flammable gases, vapors, or dust may be present. Sixthly, special occupancies. It covers the electrical requirements for special occupancies such as hospitals, schools, and theaters. Electrical codes are organized into articles, sections, and tables that provide detailed requirements and specifications. It is important to consult the latest edition of the applicable electrical code to ensure compliance with current regulations. To navigate electrical codes effectively, firstly, familiarize yourself with the organization of the codebook, including the table of contents, index, and appendices. Secondly, understand the definitions and terminology used in the codebook to ensure accurate interpretation of the requirements. Thirdly, use the index to locate specific topics or sections of interest. Fourthly, refer to the tables and figures provided in the codebook for additional information and guidance. Fifthly, consult with a qualified electrician or electrical inspector for clarification or interpretation of code requirements. Electrical codes are not intended to be a substitute for proper training and experience. It is important to have a thorough understanding of electrical principles and safe work practices before attempting any electrical work. Always obtain the necessary permits and inspections before starting any electrical project to ensure compliance with local regulations. Understanding and adhering to electrical codes is essential for ensuring the safety and reliability of electrical systems.